All right, ladies and gentlemen, we have finished with cosmology. And it was a fun ride going into outer space and everything, but it's time to land back on Earth so that we can study more about what's going on in the world around us. Yes?
I have a question.
Sure.
I was near space tomorrow. Can I take this test?
Sure.
Well, are you there? Okay.
Who's your resource teacher?
Miss Moore.
Okay, sounds good. We'll do. So now that we're done with cosmology, we are going to be moving to the next location on our structure of naturalism here. Now remember, this structure represents the overall philosophy of the scientific community today. Basically, the idea that, when we look at cosmology, there was this Big Bang explosion, and out of it, everything organized itself. And this is just the next step of that philosophical idea, that after the Earth organized itself and got a certain distance from the sun, life spontaneously arose on Earth. And that life, as a result of recombination and mutation and all sorts of things happening through genetics and DNA, gave rise to different creatures, which then branched off into the vast array of wildlife and other animals that we see in the world today. So this whole story, believe it or not, has its foundation in cosmology, in the Big Bang. Because when we looked at cosmology and we looked at space and we looked just physical characteristics, do the planets in our solar system, do galaxies in deep space, do stars, do comets, do these things look billions of years old? Or do they look thousands of years old, like the Bible says? And when we looked at these physical characteristics using common sense and real science, we found that they look much, much younger than the billions of years that they're usually given. And so because of that fact, because regular, straightforward science says things aren't that old in space, that completely demolishes this whole structure. Because if you don't have billions of years to work with here, you're not going to have enough time for any origin of life scenario to plausibly take place. So by looking at cosmology first, we actually destroyed all of naturalism right off the bat. So we could just end the class right now. Because when we look in space, things don't look billions of years old. And if you don't have that amount of time to work with, nothing makes sense here. But this class is a semester long. And we have to make use of our time. And we want to give naturalism the best chance it could possibly have to hold its own against, what the Bible tells us. We want to give it its best chance. So what we're going to do is we're going to say, okay, let's pretend we've got 14 billion years to work with. Given that amount of time, is there a plausible origin of life scenario that could take place? And that's what we're going to start exploring today. And as we do so, we are going to change the background here. You can title your notes, The Origin of Life. Enjoy the animation. Yeah. PowerPoint looks a lot better with these transitions if you slow them down. So just a little food for thought there if you're making a PowerPoint presentation. Yes? Sure. So any quotes that are unattributed in this section, go to this guy. His name is Dr. Jonathan Sarfati, extremely intelligent individual. I was able to listen to some of his lectures a few years ago at a creation conference in South Carolina. And those conferences aren't just, you sit down and you listen to all these people talk about the Bible and creation. There's fun things that go along with it. And one thing that he did is he's like one of these chess masters. So he had about 40 tables spread out in a big circle, and he played 40 people at once and quickly dismantled everybody. I was not one of them. I don't know how to play chess. It's not really my thing. But yeah, it was a pleasure to hear him talk.
Is there a video of him doing that?
There's probably one on YouTube somewhere. I haven't seen one. I haven't looked. But, a lot of times, though, people say, well, this idea of life coming from non-life, that doesn't really have anything to do with evolution. Because evolution is really just something that happens once you have something that's alive. But as Gordy Slack, who is not a religious person. He's just a secular author. As he plainly says, it's disingenuous to argue that the origin of life is irrelevant to evolution. It is no less relevant than the Big Bang is to physics or cosmology. Evolution should be able to explain, in theory at least, all the way back to the very first organism that could replicate itself through biological or chemical processes. And to understand that organism fully, we would simply have to know what came before it. And right now, we are nowhere close. And you can kind of see where this is going to be heading over the course of the next 3 days. So what we call evolution in terms of the first life is something known as chemical evolution, because these random chemicals had to come together in such a way to magically create this first living creature. And we'll start to see how likely that is today. So in his book on the origin of species, Darwin kind of speculated on this, and he said, if, and oh what a big if, we could conceive in some warm little pond with all sorts of ammonia and phosphoric salts, light, heat, electricity, etc., present, that a protein compound was chemically formed, ready to undergo still more complex changes. So in other words, I wonder if we just had the right mix in this warm little life-giving pond, if we just threw the right things in there, maybe if we give it enough time, we could eventually end up with a very simple cell. Go ahead and write this whole thing down, and we'll talk more about that. There will be a good amount of writing today, so I apologize for that. The other days I think should be a bit lighter. How many people have heard the term primordial soup before? 1, 2, that's all? Okay. So when we hear about this primordial soup, it's kind of this supposed ideal mixture of water and other things in this nice little pond that would allow life to just sort of arise out of it. You kind of think of it as, like if you think of a warm swamp, anything can grow in a swamp, bacteria or anything that you want. That's kind of what's pictured here. So oftentimes we hear about life first forming in this warm primordial soup containing water and a couple other things. So for life to have any chance at forming here, amino acids, which are of course the building blocks of life, you might remember that from biology, they have to come together on their own to make very long chains of complex molecules. And that would sort of be like step one in getting life to just spontaneously arise from non-life. You need these amino acids to form these really long chains. So a couple of things are going to go against this straight away and blow this out of the water right before we even get out of the gate. Long molecules of amino acids are unstable and they naturally break down. If they're in a warm primordial soup, if that soup would contain water, which it always does in these scenarios, that water, one of its properties is that it drives these amino acids apart from each other. If you would happen to get a bunch of them, hooking together to make a long chain, water would eventually drive them apart. It's a process known as hydrolysis. In addition to that, you would need only left-hand forms to come together for each amino acid. Did you guys know that amino acids come in left and right-hand forms? Is that big in biology or AP Bio? No? Okay. So the thing with amino acids is they come in, they look a certain way, and they can look like a mirror image of that, kind of like this right here. And if you're going to get life to form, life is unique in that all of the amino acids involved in its production and creation would have to be left-handed. But if you've got a random mixture of amino acids in this nice warm primordial soup, all these amino acids are being created randomly, remember, so you'd realistically have a mixture of right and left-handed things. So if you even just had one right-handed amino acid, hooking up with a left-handed amino acid, you would have to start back from scratch. The thing would break down and you'd have to start all over again. So that's known as the chirality problem. But they're both very big and serious issues for this. Go ahead and write this all down too, please. There are several places in this class where we get to cut Charles Darwin some slack, and this is one of those places. So in the 1800s, people did not know a whole lot about cells in and of themselves. They didn't have powerful enough microscopes. The technology wasn't quite there enough so that they could see what was really going on inside of them. So in his day, everybody just thought that life from non-life, spontaneous generation, was possible and plausible and likely. They had no idea the structures that were involved in even the simplest cell and how complicated they would be. They thought that cells were just a simple lump of albuminous combination of carbon. In other words, not complicated at all. Now, who in here has taken biology? Hopefully everybody. Tell me, is the simple cell simple?
No.
No, it is very complicated. And when we're dealing with this supposed simplest cell that first evolved, it is no more simple than the quote-unquote simple cells that you guys dealt with back in your biology days. Spontaneous generation has never been observed. There has never been a circumstance of life seemingly arising from non-life. It always comes from life, and that's actually a law, just like the second law of thermodynamics that we talked about in cosmology. This one's known as the law of biogenesis. It was first penned by Louis Pasteur, who was a scientist who believed the Bible. So in the same way that nothing has been observed going against the second law of thermodynamics, that messes up the Big Bang. Nothing has been observed going against the law of biogenesis, and that messes up the whole idea of life spontaneously arising on its own and coming out of nothing. In the present day, we also know that cellular information content is very high. We'll talk more about that near the end of class today and the start of class tomorrow. And in addition, even if somehow you did get just the right things, linking up in just the right ways, so that life spontaneously did arise in this nice, warm, beautiful, primordial soup, if that cell does not have the means to replicate itself and pass its information on to the next generation, then when it dies in a few months or a year tops, then you're going to be back to square one, and it's not going to matter. So again, we can cut Darwin some slack here, because back then they didn't know all this, but there's no excuse now. There is nothing in our world today that would give anybody the idea that life can just spontaneously arise from nothing. Now, I have a question for you. How lucky do you guys feel right now?
7.
7? How about out of 10? How lucky do you feel?
7.
7?
7.
8,
So we're feeling pretty lucky today.
2,
How lucky do you think you'd have to be to win the Powerball right now?
100%.
Anybody know what the odds are of winning the Powerball right now?
It's like 1 billion or something.
Pretty close. 1 in 292,201,338, to be exact. For our purposes, let's round up. The 1 in 300 million. Now, being able to observe these simple cells right now today, they have certain characteristics that we can actually mathematically try and figure out what the probability is of these simple cells coming together on their own. And that's what Dr. Sarfati has done. And if you're interested in why this equation looks the way it looks, feel free to see me after class or something, and I can talk you through that. But basically, to get life, to get the absolute minimum life requirement, you need at least 20 amino acids, 387 proteins, and 10 conserved amino acids on average. So, all you do is you plug these numbers into the equation, and you can see the percent chance of life arising by itself. So that turns out to be the percentage of 10 to the negative 5,035th. To kind of put that into perspective here, that would be 0.00005,000 1% chance. In other words, one chance in one with 5,000 some zeros after it. And this assumes unrealistically perfect conditions and an absolute minimal life requirement. So, that is a much larger number than hitting the jackpot today. This is, you got, what is that, 8 zeros compared with 5,000? Can you imagine how difficult that would be? But the scientific community has an answer for this. So if we're going to assume, as I said we were going to for this section, that the universe is billions of years old, well, heck, if you've got billions of years to work with, well, maybe that makes this a lot more likely. So there's a way you can account for that. Let's say that we have these exactly perfect life conditions in this warm pond for the entire time that the universe has supposedly been in existence. These 14 billion years would correspond to 10 to the 18th seconds since the Big Bang happened. There are 10 to the 80th atoms in the universe, or so. We haven't counted every one, but it's an estimate. And at best, we are going to have 10 to the 12th atomic interactions per second. So basically what we're saying here is we're saying, okay, let's turn our entire universe, all the atoms in it, into an experiment to try and get life to pop out from non-life, just by having these atoms interact with each other. So, if you account for all this time and all of these atoms coming together just perfectly in this nice warm primordial soup, let's see what happens to our likelihood. Well, it gets quite a bit better. Instead of 5,000 some zeros, you got 4,900 zeros here. One chance in 4,900 zeros. So yeah, it does get quite a bit better. That's a lot of orders of magnitude there, but still nowhere near reality. So even if you have these 14 billion years of time to work with, it's still just amazingly unlikely. And again, even if you did end up with one, if it did not have the ability to reproduce or the ability to pass its genetic information to another generation, you'd be back to square one after it dies. Sir Fred Hoyle, a Cambridge University professor who is not a Christian, puts it like this: the likelihood of the formation of life from inanimate matter is 1 to a number with 40,000 zeros after it. It is big enough to bury Darwin and the whole theory of evolution. There is no primeval soup, neither on this planet nor any other. And if the beginnings of life were not random, they must therefore have been the product of purposeful intelligence. And that's really what this all points to. Now, as I mentioned, he's not religious, but a lot of honest scientists acknowledge this, and they go their own way with this information, and we'll get to that in day 3 of our notes here. So this is an interesting quote from Richard Dawkins. We've heard from him a couple of times. He's the guy that's really antagonistic against people who believe the Bible and believe that it's supported by science. And he says, "There's enough information capacity in a single human cell to store the Encyclopedia Britannica, all 30 volumes of it," that's what we had before Wikipedia, "3 or 4 times over. The difference between life and non-life is a matter not of substance, but of information. Living things contain prodigious quantities of information, and most of that information is coded in DNA." So what's he talking about here?
I have no idea.
Right? And that's what the next couple slides are for. Go ahead and write this down, please. We'll start to make sense of this. So when we're thinking about something known as information theory, here's kind of the introduction to it. You know, when you read a book, it has information in it. You can read it, you can interpret it, it has meaning. So the information in a book is not based on the properties of the ink molecules that make up, the letters on the paper. The information in a book is, though, based on the way that they are arranged into letters, words, phrases, sentences, and paragraphs. If we didn't have language, if we didn't have speech, then none of these letters would mean anything when we saw them on the page. So you have to have a language that these letters can be interpreted within the context of for them to have the meaning that we find inside these books. So, go ahead and write this one down too. So again, I think we can all agree that there's lots and lots of information in books. The bigger the book, the more information there is. There are more letters, more phrases, more sentences, more character development, the bigger that book is. So again, even though the letters which give that book meaning are made up of ink, there is nothing about that ink itself that would cause it to join up in predetermined ways to form letters and words that you're reading. Doesn't matter how long you take an ink an ink pen or something, and you swing it at the page of a book, you're just going to get a random splotch of ink all over the place. It's not going to naturally form itself into vowels and consonants. In the same way, your DNA is basically your body's instruction manual. Because of it, you look the way you look, and you work the way you work. So there's nothing in the chemistry of your DNA or your body's instruction manual that would cause them to join up in predetermined ways to form letters and genes. So there is nothing inherent to amino acids that are going to cause them to link up in certain ways to make a big long DNA strand that would ultimately create you or an animal or the first living cell. In the same way that you can't shake ink at a page and expect it to form sentences and words and phrases. And one more thing for you to write down here then. as you finish writing this, then I'm going to try and wrap this up here for today. So, again, for a book to have meaning, it needs ink molecules arranged in the form of a preconceived language so that it can be interpreted. Without a language, without English, then all the books that have all of our, English in them would not make any sense. Romeo and Juliet, the novel written in English, would make no sense if English wasn't a thing. For a cell to have life, it needs DNA molecules arranged in the form of a preconceived program so that it can function and reproduce. Without this program, you're not going to get even the simplest living cell. That kind of begs the question, Mr. Hathaway, what do you mean when you say program? Let me just kind of run a little experiment with you here. We all have phones, right?
Yes.
All right. Now, let's say you take your phone and you remove the back of it. And you look at what's going on in there. You're probably going to be pretty impressed. There's all sorts of sophisticated microchips and crazy technology going on inside your phone that you can see. It's got amazingly sophisticated hardware. Now let's say that you come to school late, and Mr. Wallersheim takes your phone, gives it to Miss Knox, and she doesn't like you. So she wipes all the software programs off your phone. What's going to happen when you try and turn on the flashlight?
You can shake your phone and turn the flashlight on?
Yeah, it's a cheap Motorola. I love it. If you try and turn on the flashlight, but there's no program written on here to turn on the flashlight, it's not going to turn on. When you press the on button, nothing's going to happen. Even though if you open it up again, all of the hardware is still there. But if you don't have any software running, it's as good as dead. It's as good as a brick. And if you remove all of the molecular software from you or me or the simplest cell, it's as good as dead too. And the same thing is true when we're talking about life here. Life needs a program that can make it operate. It's not just, see, if we're thinking of life as just the right amino acids linking up in just the right ways, we are grossly underestimating what is necessary for life to happen. Those amino acids have to be programmed to do something, otherwise they're as good as dead. This is why Professor Paul Davies, Arizona State University, says this about the origin of life. How did stupid atoms spontaneously write their own software? Nobody knows. There is no known law of physics able to create information from nothing. But even the simplest cell has crazy amounts of this information present in it. And I mentioned things like molecular programs that are running in these cells, and I'll show you an example of that tomorrow. But again, when we think of life, the miracle of life is not just having the right things link up in just the right ways. The real miracle is all of the sophisticated molecular programs that are telling all the amino acids